So next step in thinking about conditioning information, instruments and managed portfolios. What we did so far is we took 0 equals ET of MR, conditional information on the agent, and we conditioned down to the unconditional mean. You might worry, we're going to lose a lot of power in just looking at unconditional means. Can we do something about that? Yes, we can. And here's the trick. If the agent sees ZT, then ET of MR times ZT, we can bring the ZT in and out. It's a constant from the information's point of view. It's in time t information. And then we can condition down to 0 equals E of MR times ZT. That's created a new implication for us, something that adds power that lets us see if the conditional mean is really doing what it's supposed to, as opposed to just the unconditional mean. For example, we could have, based on our first logic, just checked, is the unconditional mean of m times r equals 0? Maybe yes, maybe no. But now we need more implications to generate more powerful tests. Well, if we want to see if E of MR times Z is 0, one way of thinking to do that, let's run MR on Z. And can Z predict MR? That's a more powerful implication than just, is MR 0 on average? Can Z predict it or not? That's another more powerful way of doing it. Another way of looking at exactly the same regression, if you read ahead a little bit, you can do the GMM approach. Simply asks us to look at unconditional moments, E of MR times Z. And MR times Z, that's the covariance term on top of a beta, so it's essentially the same test, but it's another implication. It's from that point of view, we're adding instrumental variables to add power and to let us see whether the conditional, a little more information about whether the conditional mean of MR is 0 as well as the unconditional mean. There's a third way of looking at the same thing. E of MR times Z, we can think of Z as just an instrument or a regressor, forecasting returns in the 70s tradition or GMM in the 80s tradition. But we can also unite RE times Z. Now, RE times Z is a return itself. It's a managed portfolio return. What does a hedge fund do other than look at some signal Z and invest more or less in an excess return strategy according to that signal Z, and then report the return to its investors? So an instrumental variable is the same thing as a managed portfolio return. And now you see that by adding instrumental variables, managed portfolios, that's just like adding more returns to the space. So this managed portfolio theorem is another beautiful uniter of the things we do. It tells us that the time series is the same as the cross-section. Running time series tests, can we forecast with regressions, is exactly the same thing as forming managed portfolios and then doing unconditional tests with the expanded managed portfolio returns. The managed portfolio theorem. An example you've already seen, Fama and French has 25 portfolios. Fama and French, in their table 1, didn't look at individual stock returns. Every year they reformed 25 portfolios using book-to-market ratios and size, which are variables known to forecast returns. So they were exactly incorporating time series information by doing an unconditional cross-sectional test using managed portfolios. Another example, empirical asset pricing uses the returns of hedge funds and mutual funds all the time. What are we doing then? Well, we can just use unconditional asset pricing, cross-sectional asset pricing, using hedge fund and mutual fund returns to see if the managed portfolios they're using to incorporate information tell us something about our asset pricing models. So time series is the same as cross-section. Regressions are the same as portfolios. There's another camp that we don't have to divide. We're really all doing the same thing. Last word here is sufficiency. So you've seen that by adding instruments, we're able to get more and more power. How far can this go? Well, here's a theorem, another theorem. If 0 equals E of MR times Z for all Z in an information set, then in fact we can say the conditional mean of 0 E of MR is 0. In other words, the definition of conditional mean is the same thing as all linear and nonlinear regressions put together. So at least conditioning information set generated by a set of variables, in principle, once you've put in all the variables as instruments, you've got conditional expectation. That's a large set of variables, but at least you know that you're fishing in the right sea.